Okay, hello everyone. Can you hear my voice? Okay, that's good. Is it here 365, right? Good. Okay, good to see you again. Do you know my name? It's a long time. I'm JJ. From today, for 2 weeks or 3 weeks, we'll cover intercept communications and the cryptography and access control modules. So yeah, I really appreciate your great job on module 4 modules so far. How was that? Great. So that's a great way to run the practical cybersecurity, right? So this way, the characteristics of this class, yeah, we will deliver the practical knowledge in the cybersecurity. Also, uh, we like to introduce the theoretical knowledge of cybersecurity, but that's not fun. That's not the same on this challenge-based the learning curve. So today I will try to deliver the both side, but uh, also I'll try to make you feel the fun of the network security. So okay, so what are your expectations of these topics, the intercepting communications or network security? So everything is connected via the network, right? These days, our devices. So even the car, the vehicles, or we call that the IoT, Internet of Things. So everything will be connected by one network. I mean, through the network technology, the Internet network technology. So if you have vulnerable network infrastructure or device, so that will be yes the great target from the hackers. So, what kinds of attacks in networks? So have you ever heard like a DOS attack, denial of service attack? So you can send a bunch of the packet traffics to the target, uh, like a company website or your friend website or your neighbor home router, so they cannot use their network or devices uh, properly. So there is one way, what a good attacks of networks. What else? Can you cheat your network identity, like your IPs or port numbers or your usernames on the website? Anonymous. That is also very prevalent in the networks. Anyway, yes, everything is a software, so we can modify, right? So I think you saw the reverse engineering catch that, like license keys or some the hidden part of the images. So everything's softwareized, so we can see the original source by reverse engineering. Like that, we can scoop, we can modify the content of the network protocols, network packets. So that is the covered those kinds of attacks covered in this class, like IP spoofing or port, the TCP port spoofing, ARP spoofing. Okay, so I guess you didn't understand what I'm saying. The term, a lot of terminology in the network security. So, how many of you take the network related course? No, no. So, but you know the what is IP, right? What is the phone number? Phone number, and what is the like a MAC address or physical address? Okay. So this is not a network class, but uh, yeah, I will teach some basics for the networks, but I will focus on the security of that knowledge networks. So in internet, based on the implemented on this standard, the this side is a TCP/IP, and this side is the OSI. So OSI is a reference model. What is that? That is a theoretical model. That is that uh, they do not. The OSI model didn't give the details how to implement it, how it works, how it should be designed, but they just provide some policies or rules or specific designing techniques. So based on these OSI, so we can design some applications. One of them is the TCP/IP. As you can see, they have some different layers, right? In case OSI, we call that seven OSI 7 layers, but TCP/IP, we call that a 4 layers, right? There's only 4 stacks and 7 stacks. So each stack, each layer, logically mapped with this protocol. So the in the middle, I put the various types of protocols from the Ethernet to the HTTP. So these protocol names, I think you may be yeah know you may know some of them. Yeah, using this protocol, they talk each other. What's the meaning of protocol? Protocol, in a nutshell, I can say that's the promise or the rule, right? So if you like to talk with me, you should keep this rule. So that's like some format or some requirement, right? So if you follow this set of rules or compliance, yes, I can talk with you. So that's the basic the philosophy of these protocols. So the TCP/IP, the TCP/IP, uh, actually they combine the two protocols, IP protocols and TCP protocols. So these protocol is the foundations of internet. Okay, so each layer, yeah, the functions of each layer they have different the characteristics, but the what is the key functions of each layers? So first the network access or link layer. That is the first layer, right? From the physical layer. What is a physical? Physical means like electrical lines or the line we call that the cable, right? Uh, so from that the wire, uh, we should convert that analog signals to digital signal to be processing in the computer, right? So network access the convert that physical signal to digital signal and labeling every entities of the of that physical entities. Okay, so to communicate, so what is the what which information you need to communicate? Let's say when you call your friend, so what like to know first? number, right? How about a letter? What is the first? Address, right? So number and address. So that's first entity, first the object in communication. So each layer they have their own number or address. So each layer, in case the this network X layer, they use physical address or the MAC address, and internet they use IP address. The TCP they use the port number. The application they use some session information. Like this, each layer they have their own or unique address or number to communicate among the each layers among layers and also among some other the participants in the network. Okay. So any questions about this model? OSI 7 layer and TCP/IP 4 layers. I'd like to start with these commands. Ping. Anyone knows? Anyone know this commands? Ping. What is this? Okay, this is the um, it, I learned the WSL on the Windows PowerShell. So Windows just they provide these with sub layers of the Linux. So let's ping where 808. What's the 8.888? You don't know? Okay, when I learned that commands, yeah, they reply with some informations here. So 8888, that's the public DNS server of the Google. So they open this DNS server. So I just ping that server. The ping is live or dead. So the goal of the ping, yes, so test the reachability, the device or the network device. Okay, server or device, network devices. So as you can see, ping he sent ping command send 56 or 84 bytes sent, and the received 64 bytes from the server. What's the name of the protocol? The ICMP. Okay, sequence number one, and TTL. Anyone knows what is the TTL? Guess what is the TTL? The time to live. Okay, and so this time indicate the delay 13, 14, 20, the turnaround time. Okay, so when you feel some delay in your network, so you can check like this in this way. So they uh, they provide this information of some delay or some the failure or in some point. You also trace a trace a lot. Oh, okay. What is it? Trace a lot. Trace a lot. I didn't remember that comments. Trace a lot. They show the hoping server by the end of by the server, the designated server. So we can see the one which server or what is the failure in that network route using this the comments. Okay, let me check again. Ping. So use the one of the protocol name is the ICMP. Okay. So you can see this ICMP, and I'm trying to catch the packet, right? Ping again to Google, and I will learn Wireshark. So Wireshark is kind of IDA Pro in reverse engineering. So in network, also the Wireshark give us a lot of the information to analyze the packets. So I will set up the interface here, the Wi-Fi. Yeah, a lot of the packet I captured. So I just ICMP packet filter and learn. Okay, yeah, you can see the captured packet, right? So stop. Okay, let me break down one packet here. So I will have another separate class for the Wireshark, but today um, let's just see the outline of the Wireshark. So the frame means overall information of this packet. So they show the total size like 98 byte length. Okay, and I will this Ethernet 2. Actually, the Ethernet that is the protocol in the data access network layer or the link layer, the first layer of the TCP/IP protocol. Okay, so you can see the Ethernet 2, right? And next, the IP protocol, right? And then ICMP, the protocol. So we can see these three stacks in the ping packet, right? In the Ethernet, that's the first layer, right? They use, as I said, the MAC address, right? This hexabyte C4 3D 1A. So it gives the destinations. Um, this is the source C4 E9FA. These are 6 hexabyte. These 6 hexabyte that indicate the source destination source MAC address. That means this device, these laptops, MAC address gonna be C4. What's destinations? So Cisco, the 009FF F092. So I ping I pinged 8888, right? But the destination is not 8888. The destination is the Cisco, maybe the one of the switch in this room, right? So what's the mean? The packet reach the packet I received the packet just from the last network device like a switch or mobile router. They send me this packet maybe because the networks. So if I send the packet to the google.com, but the packet is not directly reach out that Google, right? So there are the multiple hopping server, multiple repeater or multiple server exist in the network route, right? So the destination is not Google directly. So here in the Cisco switch, right? Also the destination's address has 6 bytes. So source for these laptops, right? So based on this address, they identify which device sent this packet or where do I give this where I give this packet to the sender, like that. This MAC IP, MAC address or physical address is the layer two address, layer one, the first layers, and internet protocol. So it has also source address, right, and destination address. Here I can see the destination address for 8 I specified in the command line. Okay, so actually the ping 8888 it has to go through the our network devices. The first network device, like a mobile router, that is the first the network device, right? And then it will route to another uh, the network switch or any routers again, and then multiple hopping steps. After the multiple hopping steps, eventually reach out that destinations. So in the IP protocol, what is the key factor? So the source address and destination address, right? And time to live the 63. So that is shown here, right? Time to live version, and the type of the protocol, that's ICMP, and header checksum for integrity check or error check. Okay, and then we can see the ICMP protocol. So ping implemented based on this protocol, right? So type 8 indicate that's a echo request. Okay, and, and it has a data like this. And then let's see the reply packet of SMP. Okay, everything the same, but the address is reversed. Source, so source address in the Ethernet layer, that the Cisco switch, routers, and destination it is laptops. And Internet protocol, yes, source 888, destination is laptops. Okay, ICMP. So in echo reply, the type is 0, but request, the type is 8, right? So they can be distinguished in this type byte and data like this. So Wireshark is a good way to analyze a packet in this way. And so that's the ping, okay? So ping request type is a 0, OX0, right? OX means a hexabyte. And echo reply is type is 0. Request is 8 and reply type is 0. Okay. They show the RTT these times. Okay. And second command, I like to say the IF config or IP config. So in the Linux, IP config show the TCP IP configurations. Let's see the same shell. Okay. In Linux, what is that? IP config or and with the A options, they show the all interface. So IF means interface. So interface config and with the TCP IP informations. So what is the first? ETH0. ETH0, what is that? Uh, Interface name. Okay. And then the Plex setup like up means, yeah, it is this interface is up, the running uh, successfully, and broadcast and running and multicast. The this device can be multicasted and broadcasted. What's the mean broadcast? Now I'm speaking, right? You are hearing my voice, right? That's a broadcasting. Okay. But multicasting, I select only this side persons. So I only say, and you can only this side can hear my voice because I select these specific groups. So that's a multicast. Okay. So this device can support this broadcast and multicast. MTU. What is the MTU? The maximum transfer unit. So this device, the default maximum transfer, the size of packet gonna be 1500, 1500. Okay. So the address assign the address, the 172.130. So there's a IP address first, and then mask and broadcast address. So what is the net mask? What is the net mask? So we wear our mask during the COVID pandemic, right? So what's the net mask in the TCP/IP? Okay, and the INET 6, that is the IP version 6 address. So yeah, there's two types of address IP version 4 and IP version 6. But currently uh, most of us use IP version 4. But I will revisit again this IP version 6 again later. And the Ethernet address, right? So this IP address mapped this physical address. And they showed us some statistics information, how many packets it received or transmit, okay, and states of errors, okay. And second, interface LO. What's the meaning of LO here? You can see here the loopback. What is a loopback? Yeah, these laptops itself. Why we need it? Sometimes we need to check the network functions of these laptops. So we can send like a ping local host like this. Yeah, this address 127.0.0.1 is a fixed address as the local loop interface. Okay, in this way, oh, network device working properly, so I can check. Okay. So in the same in the Windows we use for the same functions IP config, config and slash o. Yes, so a lot of information here. So we do use IP configurations and so wireless LAN. So yes, it has the this IP address here, IP version 4, right? And also it has a subnet mask. So I asked, what is the net mask? So I will talk later. And yes, assigned timestamp, okay, and expired timestamp. Okay, the gateway. That is the last network device with these laptops. Okay, that gonna be mobile router in this environment gateway. So how can I check the gateway's live? Because I can ping that gateway address here. Okay, it is alive. Okay. Okay, so we can check the TCP/IP informations using these two commands. Also in Linux, another commands IP address show. Yeah, that can get the same, but some different the extra informations. And also in the PowerShell and Windows, we can use get net adapter. the more strict, more straightforward commander. Yes. So actually, these commands give us more information, like some interface number here, okay, and status, and MAC address. That's our physical address, 6 byte, right? And link speed. Okay, what is a subnet? So subnet dividing a larger network into small division. So yeah, that's a nonsense to manage a whole network with one network, right? ASU has also we have a lot of the colleges, separate colleges, right? And also the college has the different some the schools, and schools has different majors. Like that, some networks should use some hierarchical management schemes. So in the network, we can also divide the huge network into the small network for the efficiency or some performance reason. So um, I have config again. So this IP address 130 and then mask to 240.0. What's the mean? So I put that address in this IP calculator address, the website, and it showed the result of these calculations. Yes, my IP address 130, right? And then mask, so 240. That means 20. So what's the mean of 20 here? That is the number of this one, right? So IP address usually composed of two parts. The first part, um, first part here we call the network address, and second part this zero we call host address. So this the number of one or number of zero uh, that indicate the number of networks and number of hosts. In this case, how many one in these calculations? The 20, right? So 2 to power of 20, we can have the networks. But the zero, how many zeros are there? 12, right? So 2 to power of 12, so that's gonna be number of the host. So in this way, we can separate the divide the whole network into small networks. So the 20, that's 10, the number of the network bit, right? So in this case, the wildcard, that's a reverse of the network bits. That's gonna be this one, the 15 and 255, 20, 50, 255, right? So uh, network address can be represented by this uh, 28 slash 0. That means the class B. So what is the class B? You will learn later. And broadcast address can be set up like this, all one in the host address and this network address. So that's gonna be 172 and 255. So what's the minimum of the host? The all zero. What's the maximum? All one. But last one that can be used for the broadcast, right? In here. So the host for network can have the host the 4094. That is the same like here then must 2401 and broadcast 95255, right? So broadcast 95255. Okay. So like these, the networks can be subnetted and calculate the number of networks, number of hosts, and how many hosts can be joined in that subnetwork. So the class IP address has class A, B, C, D, E. In the first stage of this work, the TCP IP has static range of each class, but that's not efficient, right? The static means there is a limitations and constraint to join that network class. So sub networking, that is the technology to overcome that limitations. So IP version 4 composed of 32-bit address, but IP version 6 can support 128-bit address. So the number of bits indicate how many networks and hosts can be represented. So 2 to the power of 128, I cannot calculate. Anyway, theoretically we can design within this scope. So in IP version 6, they consider the proliferations of network like IoT devices or like the different radio technology like a 5G or 6G. Yeah, in that ultra connected, low latency internet, maybe sometimes we experience the lack of IP address. So IP version 6, that is the alternative to resolve that issues. Okay. So we call that the first stage of the IP addressing. So classful addressing, the static A, B, C, D, E. But now we are using classless addressing. Uh, like we call that sometimes the slash encoding method, like a slash 24. That means we have 24 network bits. Okay. And so 24 bits used for network portion, and last 8 bit used for host. So 2 to the power of 8 means 256. The 256 host can be used, but the last one should be used for network address. So 255 can be used for host for this in this subnetwork. Okay. Based on the slash 8 or 16, 24. Again, this is the number of the network bit, right? So that the decide the number of networks. So the network's gonna be in the 8, 2 to the power 8, the 1 to 8, 2 to the power 16, they're gonna be 16K, and 24, 2 million. Okay, in this way, and this is the host address. So we can adjust the number of this slash bit and make the new subnetwork for the specific size what you want. So that's the way to handle the network now. So okay. Also, you heard these terms public IP or private IP. What's different? The public IP is only unique worldwide internationally, right? So no one can share that using that same IP for the public IP. However, how about private IP? So currently, my IP, so 172, is it public or private? Definitely private, right? Because yeah, this network, this is the WSL, so like a virtual network in the Windows. So Windows cannot provide public IP to the virtual environment. So this is the private IP address. Or how about this, the real world IP address connected with connect IP config. This is the real the connected ASU network. So you can see 12192. Okay. Oh, this is the PM. Yes, this is the real IP in this laptop. 10 start 10, 155, and 18618. Is it public or private? Private, right? So most IP we use, yeah, those are private. So there's a specific range for private and public to avoid the confusion or conflict. So in case of class A, the public start from uh, this address, the network portions of the IP start from 0 to 126, and class B and class C. But the private start from 10 and 172 and 192. Those IP, we call that private IP address. Okay, so this private IP address usually assigned by what? The mobile routers, right? Or so we call that DHCP server, or sometimes NAT, uh, network translator. So they will assign the private IP address within their subnetwork. Why? So the public IP is very expensive. So the one organizations or institutions, they have only some two or three IPs only. So they use that public IPs to routing, but internally they use private IP address. Okay, that's the differences. So second, I said the MAC address the first layers of the TCP IP, right? So they use this 48 bit, so that 6 byte used for the physical address. It has two portions, OUI and NIC. So this is the manufacturer unique manufacturer produced number, and the NIC, that's the unique number the manufacturer assigned. Okay. How can we see the MAC address? So we can use the ALP commands here. So ALP, that's utility. ALP-A. So there's only one table, but in the Windows ALP, yeah, you can see a lot of tables of mapping um, the IP address and the MAC address, right? Uh, why we need this table? So as I said, this device, when I ping the Google, they do not reach out the google.com directly. So we just send the packet to the next the network device. What is that? The, like a mobile router, right? So these tables, like in this case, it has only one cache, one the MAC address. Um, okay, so this is the gateway or the network device, the MAC address, only one. Because this is the virtual environment, but in this Windows connected with the ASU network, they have it has a lot of the mapping tables between the IP address and physical address. Okay, so it has this mapping table, so we call that ARP cache. Okay, so sometimes we can spoof of these tables to uh, the make the user the connected the fake some site or fake some the destinations. Okay, so let's visit our dojo. Um, so you can see the intercepting communications. Here you can see some helpful. This is the previous semester material, also corner materials. Okay, and let's get level 1. Okay, SSH. Connect. Okay, let's see the challenge. I will challenge, right? And long. Okay. Okay, welcome. So in this challenge, you will connect a remote host. So we need connect tool, right? The target is the 10003. The listening port 3177 31337. Yeah. So to solve these challenges, we need one tool. So that is the netcat. Okay, netcat. Uh, yeah, this is the current my IP address. What is that? 10002. Okay, then mask broadcast. Okay, so this is the virtual network. So some value maybe shows so in abnormal values. Anyway, I will ping 10 to 1000 3. Yes, the target is alive, right? So how can connect? We should use nc command or nc utility. So we can what can I delete? Okay, I like to delete the terminals, but I forgot that key. Anyway, man nc. So nc is used for just about anything under the sun involving TCP UDP or Linux domain socket. That it can open TCP connection, send UDP packet. So the TCP and UDP connections be supported by the NC netcat. Okay. Um, so you can see options the dash 4 that's a version IP version 4, okay, and version 6 for and B allow broadcast and C stands shell F T. Okay, so what is the the dash L gonna be the key options in challenges. So dash L makes the listen mode of the commands. Okay, and you need to specify the port. So you should use the P dash P. Okay, so with this knowledge, okay, again, we should listen this target IP on this port 31337. So we can use NC, so target 10.0.0.3 and P 31337. Okay. Oh, target port, so we don't need to P options. Yeah, they showed us the flag, right? Uh, so this is the very easy challenges. So as commands, okay, also we can like that chatting mode. How can you that that nc okay, localhost port 10. Oh, uh, so nc is l 10.0.0.3 and msp 31337. It's L. Let's see. And try to connect localhost port 1000. No. SP. Okay. So 1000. Okay. NC. Okay, let's use. Yeah, like this, we can connect some specific site using NC. So I like to connect NC localhost, and I don't know why, because I like to chat with this setup, but maybe they are in the virtual space, so they not. Don't know why. Okay, NC L mode and 1000. Okay, suit and okay, NC localhost and 1000. Yeah, you can see. So when I type something, uh, so this terminal reflect that, receive that key, right? So like this, NC can connect the website, any server, and exchange some data in this way. Also, NC can transfer some files using some directions. Yes, NC slash L and P. L means yeah listen mode, and P specify the port. If you can transfer some files using NC, using these options and the order and port. Also, NC can use for scanning. Okay, so maybe challenge one and some challenge two. You need to use these tools and NetCat. And also, challenges 3 or 4, you need to use the nmap. Okay, let's see the challenge again. Here, number 3. This. Okay. See. Correct. Okay. So let's see the challenge in level 3. Yeah. This challenge, you will find the connect the remote host. The remote host is someone, yeah, here you can see the subnetwork, right? So 10.0.0.0.20/24, what's the mean? So 24, there is a 24 ones, right? From the network sessions. So first 8 byte, first 8 bit, second 8 bit, and third 8 bit. So 24 bit, all one, right? And the last 8 byte, 8 bit, 2 to 8. So 256. That is only the number accessible, connectable in this network. Make sense? Okay. So how to find the specific tools, specific host listening on 31337. So in this case, you need to use the nmap. Okay. So nmap is a network mapper, maybe. So they scan all network to discover some open port and the version of server, sub OS like a Linux or Windows, and also they give some more informative stuff using these tools and maps. So here a lot of options: IL, SL. So here I like to use just the TCP sync scan. So we will have later the regarding TCP. What is the sync or ACK? So those the packets used for scanning in Nmap. So here just I can use Nmap like option SN. And what's the target IP? 10.0.0.0/24, right? So let's run. So it takes some time because yeah they scan the IP one by one from the 10.0.0.0 to 10.0.0.255, right? Because uh, that's the 24 subnet mask. So here, this server and this one, there's a two, right? Hosted up, right? So I like to ping 10 and 0.0.147. Okay, yes, it's all right. Okay, so um, how can we connect that server? So what are the challenges? What was the challenges? So find the connect the remote host, right? Okay. For networks. So we found this one, and there's two, but 10.0.0.2 is myself, right? This network. Hey, how to connect that remote host? We can use NC, right? And what's the target IP? 10.0.0.147 and port 31337. Okay. Okay. Yeah. So dash P means source port, right? So when you try to connect the remote server, remote device, just put the port number without dash P option. Okay. And this is the challenge 3. What is the challenge 4? Let's see. Any questions? Okay. Challenge run. Okay. Oh yeah, they just changed the target IP subnet, right? From 24 to 16. What does it mean? What does it mean? The subnet is changed. Subnet mask change from 24 to 16 in challenge 4. Anyone knows this means? No. The number of hosts increased, right? The 16 is the first 8 bit and second 8 bit all set, right? And third 8 bit, fourth 8 bit. So 16 bit should be can be used for host, right? So 2 power of 16 what's the number? 164? 164K, right? The number of hosts is 164K. So when you run the nmap to scan the host, it takes longer and longer time than challenge 3, right? Nmap minus n plus and target 10 0 0 0 16 so net. Okay, but there's options like a T large T 4 in nmap. So large T4 option is timing template options. When you put these options, the nmap increase the speed to scan. So when you like to speed up in nmap, you can use this dash T large T4. Default is a T3, but if you improve the speed, you can use the T4 options. But I expect a long delay maybe because to follow 16, the 64K host not easy to scan or the number of IPs maybe, right? Host IP address. Yeah, it shows the delay because the number of hosts are increased. Anyone, any doubt? No? Okay, the lastly, let's see. Yeah, we skip the result here. Level 5. Let's see, challenge, run. Okay, you have to monitor traffic from remote host. Your host is already receiving traffic on port 31337 or monitor, right? So now, just the previous challenges, they are focusing on the connect, right? And discover the network. But in the challenge 5, make you monitor the traffic. So this is a different tools you need. I'd like to introduce the tools TCP dump. Okay. So TCP dump, that's a packet analyzer to capturing the traffics. So TCP dump is very nice tools in command line, but So I already showed the Wireshark, right? That's GUI version maybe of, but as I said, the Wireshark is like IDA Pro in the reverse engineering. But the TCP dump also the great tools in the command line. As you can see, TCP dump commands request require the interface names ETH0, right? That's an interface name. And also, if you like to filter based on the type of protocol like ICMP or TCP or UDP, you can specify the protocol name next to the interface like this, okay? And then uh, you like to also add some filter based on the target host IP address. You can specify like this. And here, port number can be add and dash large X. That options provide us very useful. They so the packet that is just also the array of hexabyte, right? But in the these X options, large X options, show us ASCII value of the hex value. So everyone knows the ASCII code, right? Human readable code. So that is a very useful to understand, analyze that packet. And also you can save the packets with this option W, small w, the small w, and the file. Oh, this typo, not a comma. You should replace the comma with a dot. Okay, that's a. And C is the number of packets. How many packets you like to save, the capture? Okay, here the 300. And last one, okay, you can specify the source IP and destination IP and the package between them I can capture. That's another filter. Okay, this is the sample captured by TCP dump. Let us see the commands. Sudo. So TCP dump request the admin privilege. So sudo TCP dump interface name here ENS 33 and double N. What's the mean double N? And dash SO S0 and V. The V means S0 means capital size. Uh, so S0 that set to unlimited size of the captured packet, and the slash V dash V give us more detailed informations of the process and port 80. So when you run that commands listening on ENS 33 interface, right? So same destination address, and also uh, here the dash A options give us the ASCII code, uh, ASCII value of the packet. Okay. Okay, let's back to the challenges. Okay. Okay. Let's call it a day. Do you have any questions? Okay, let's continue next Monday.